In this example, we're given the graph of f of x. We're going to consider this to be the parent function for f, and we are asked to graph the negative of f of 2x plus 3 using our transformation rules. All right, so first thing I'm going to do is make a column to list out the points for the original parent function. Notice it's being defined by 3 critical points here. So I'll list them from left to right. They're negative 5, 3, 0, 3, and 3, negative 1. Okay? And for this example, I'm going to graph in stages just so we can visually see the different transformations taking place one at a time. Okay, so in terms of negative f of 2x plus 3, I'm going to focus on the 2 first. That's inside the function. I always focus on anything that's inside first. We want to think about, does that affect x coordinates or y coordinates, and what type of transformation is that giving us, okay? So anytime we're inside the function, we've learned we're having an effect on the x coordinates, and it's the opposite of what it appears. So I'm going to say that my x coordinates are being multiplied by 1/2. Okay, and we've learned that that is going to give us a horizontal compressing effect. So I'm going to say the transformation taking place is a horizontal compression by a factor of 1/2. Okay, so let's make a second column down here. This is going to represent points for f of 2x. So all the points that are in black there, we're now going to rewrite them with their x coordinates having been multiplied by 1/2. Okay, now let's plot those. Okay, so there you can see that horizontal compressing effect taking place. I think it's like the black graph. It's just being sandwiched from the left and the right. Okay. All right, now we're going to move to the negative that is outside of f. Okay. Anytime we're outside, we're having an effect on our y coordinates, and it's exactly how it appears. So the y's are being multiplied by negative 1. And we've learned that this is going to give us a reflection across the x-axis. Okay, so now we've got a third column to represent the graph of negative f of 2x. So take all of the points that are in blue, take their y coordinates, and change their signs. Okay, plot those. And this is now the graph. Think of it's the blue curve having been reflected over the x-axis that you now see in red. All right, only thing left to account for is the addition by 3. That's also happening outside of the function f. So another effect on y coordinates. Add 3 to each y, and that's going to give us a vertical shift up. Three units. Okay, so one final column here. Take all of the points that are listed in red, add 3 to their y values. Okay. And here we go. Plot those. there is our final curve that we're after. If you're going to graph in stages like this, make sure you label the final graph with the proper notation there, so we know which one we're after. All right, moving to example 2 here. Notice I'm going to use the same parent function for f of x. And this time I'm not going to do this in stages. I'm going to just try to get one final graph on the screen, so we don't we don't get confused about which is the final graph. Okay, so I'll begin same way I did before, listing out the coordinates for the critical points on the original parent function. All right, and let's go one number at a time and identify which coordinates it'll be affecting and how it will be affecting them. Okay, so again, always start inside the function. So x is being added with 2. That's going to have an effect on your x coordinates, but again, the opposite of what it appears. So x coordinates will now be subtracted by 2. Okay, that's going to horizontally shift your graph to the left 2 units. Okay. Now I'll move to the 2 that's outside of the function. Okay, the 2 that's in front of f. That is having an effect on the y coordinates exactly as it appears, so they will be multiplied by 2, which has a vertical stretch effect. Vertical stretch by a factor of 2. And lastly, we move to the subtraction by 1. That's also happening outside of the function, so that's affecting the y coordinates again. Subtract by 1, and that's going to vertically shift us downward 1 unit. Okay. All right, so let's take all of these into account at the same time. So I'll make a column for the points of 2 times f of x plus 2 subtracted by 1. Okay, so in each point here, we're subtracting the x coordinate by 2. Okay, so that's going to give us -7, -2, and 1. And then the y coordinates, notice we have 2 effects on those. Make sure you follow order of operations here. So we're going to do the multiplication first, followed by the subtraction. So if I take the first y coordinate of 3, if I multiply that by 2, I get 6. Subtract that by 1, leads me to 5. Be the same for the next point as well. And then finally, -1. So if I multiply that by 2, that's -2. Subtract it by 1, get -3. Go ahead and plot all of those. And here is your final curve.